Now it is your turn to work this example that uses a linear inequality in two variables. If you have not done this question already, please stop the video, work this problem in your lecture notes packet, and then return to the video to verify your answers. All questions on this example relate to the inequality y is greater than 2/3 x minus 1. In part A, we need to check is 0, negative 1 a solution to that inequality. We begin by substituting negative 1 for the y, substituting 0 for the x, and asking ourselves, is negative 1 greater than 2/3 times 0 minus 1? If we simplify the right side of this inequality, 2/3 times 0 is 0, and 0 minus 1 is negative 1. So is negative 1 greater than negative 1? The answer is no. So 0, negative 1 is not a solution for this inequality. In part B, we need to check is 3, negative 1 a solution for the inequality. So we begin in the same way. We substitute the given y value for the y in the equation, the given x value for the x in the equation, and we check is negative 1 greater than 2/3 times 3 minus 1. Simplifying the right side again, 2/3 times 3 is 2, and 2 minus 1 is 1. So the question now before us, is negative 1 greater than positive 1? The answer for that again is no. So far, the first 2 points have not been solutions. Part C, is 0, 0 a solution for this inequality? Again, begin by substituting the given y value for the variable y, the given x value for the variable x, and we're trying to check, is 0 greater than 2/3 times 0 minus 1? Simplifying the right side again, 2/3 times 0, 2/3 times 0 is 0, 0 minus 1 is negative 1, and we're trying to figure out, is 0 greater than negative 1? That does check, so the answer there is yes. And finally in part D, is negative 6, negative 4 a solution? Substituting negative 4 for the y, substituting negative 6 for the x, we're trying to check, is negative 4 greater than or equal to 2/3 times negative 6 minus 1? Well, 2/3 times negative 6 is negative 4, and negative 4 minus 1 is negative 5. So the question before us was, is negative 4 greater than negative 5? And the answer to that again is yes. For part E, we now need to plot any of these solutions from parts A through D on the graph. We'll start by setting up our axes. We'll be sure to draw the axes with a ruler, add the arrows on at least the positive ends, add the labels x and y, and a scale. In this case I used 1, 2, 3. Of the 4 points, only 2 of them were solutions, 0, 0, and negative 6, negative 4. The complication in this example is that we do have 2 solutions, but they are not necessarily on the separation, on the line, between the half of solutions and the half of non-solutions. So again, if we look back to the original inequality, and for a moment ignore the fact that it says y greater than, but think of this as y equals, we'll again see our slope-intercept form. If we were to look at this as 2/3 x minus 1, that would tell us that our y-intercept is at 0, negative 1, and our slope is 2/3. So from that point, if I count up 1, 2, over 1, 2, 3, or down 1, 2, left 1, 2, 3, I will obtain 3 points on this line. The difference in this example is because we need the y values to be greater than this particular line, we don't want to include any points on the line. If you actually notice, 0, negative 1 was our first thing that we checked in part A, and that did not check out. Because the points on the line would always give us an equality, y being equal to the 2/3 x minus 1, we can't include any points on this strict inequality of greater than. We still need to draw the line where the line should be to give us our border, but we can't do it with a solid line. If we line up our ruler with the 3 points that would be on the line, we recognize where the separation is. But again, we cannot draw this as a solid line, because a solid line would indicate these points would be solutions. So our method is then to draw this as a dashed line. A dashed line representing the fact that here's our border, but it is not a border that's included in the solution set. This is equivalent to drawing an open circle or a parenthesis on a number line. Once we remove the ruler itself, we see the separation, we see where the border is. We again finish off drawing a line, as always with arrows on both ends, but the difference is we now need to shade one half of this number line. Having those two solutions of 0, 0 and negative 6, 4 on the top half of the graph show me that this is the half that has the solutions. So while the line itself does not include solutions, and there are no solutions below the line, all the solutions are going to be above the line. So to finish this off, we'll grab our pencils and we'll sketch in or shade in the top half of this graph. It doesn't need to be perfect, just needs to give a clear indication which is the half that has the solutions.